Yeah, thank you. I am super excited to be here. Serverless is such a new space. I'm curious how many of you have played with serverless much. You've built serverless applications, so maybe 2/3, and that would be maybe a third are kind of here to find some things out. And that's a good place to be. Developing serverless applications is different than developing applications in the past, and this has been a challenge. We come in and we help companies be successful building serverless apps. And I'm going to talk today about the challenges that we've seen a lot of these organizations have in figuring out the solutions around the software development lifecycle around building applications. So if we start out with a very simple example, your boss comes and he says to you, we need a new service. It needs to process messages from our new hardware, our new gizmos out in the world. And you say to yourself, and maybe after this conference, you go home on the weekend, and you're like, I've played with this new serverless thing, and it's really cool. I see how quickly it is to get started. And like, I think we can build this service using serverless. And because it's so easy, I'm pretty sure we could do it in half a day. You're thinking, we can do this, very confident. You maybe even taught your son how to program your little Alexa Echo, how to respond to messages, and he dutifully did that. And so you're thinking this can't be too difficult. There's lots of tutorials online. I can easily whip this out. And you start to sit down and you realize, oh, and I actually have to build a productionized system. There's a lot more to this than what the tutorials and the simple examples throw out there. I now have to figure out a lot of things around permissions, around collaboration among my team members. I didn't have to think about that when I was just building my side project on my own. How do I do all of this? On top of that, AWS has this awesome promise. They say, AWS Lambda invokes your code only when needed and automatically scales to support the rate of incoming requests without requiring you to configure anything. There's no limit to the number of requests your code can handle. And this sounds great, but then you start to realize that there's a reality to this, that AWS invokes your code sometimes when needed and can scale to support certain rates of incoming requests, but requires you to properly configure everything. There are limits to the number of requests your architecture can handle. So how do you square all of this as an organization? So I'm going to talk again today about the 4 things that we've seen organizations really have to come to terms with about how they build serverless applications. How do they deal with access and permissions management, which is, first you have to figure out how to do it in the cloud, but then you have to figure out how to expand on that with the new serverless approach. Next is collaboration mechanisms. How do I work among a team? Third is testing, and this is the one that most people first start to ask questions about, is how do I test in a serverless environment? And the fourth is monitoring and instrumentation. What mechanisms are there, and how can teams ensure that everything is monitored and instrumented correctly? So first, if we start out looking at access and permission management, we can, again, start with another simple scenario. Let's say I need to build something where I've got a serverless function that is triggered by an upload of an image to an S3 bucket called uploads. And that function is going to resize the image. It's going to save that image to a new bucket called resized. And that's going to update a record in DynamoDB, a table called resize records. So this may be what your architecture kind of loosely looks like, pretty simple. And especially if you're new to cloud development in general, which probably is not true of anyone here, but let's say in the serverless case specifically, you're thinking to yourself, I've created an architecture diagram, I've codified it into my framework, so shouldn't I just be able to access the resource, access the images in the buckets and upload to the buckets? I've set up notifications and things. And the reality is, no, what you need is to actually go through and finely tailor permissions to give your functions access to all the resources. And this is a good thing. By making it so that no functions, no compute resources have automatic access to other resources. We prevent security intrusions from spreading farther than they would otherwise. But it means we got to figure out how to do this. So we can go and we can Google for serverless permissions, and we oftentimes find examples that they look easy and simple off the shelf. Here, this is an IAM statement that you're tempted to copy and paste in that would allow access to your S3 buckets. The problem is that this is going to give you access to every S3 bucket and the ability to do anything to that bucket that you might ever want to do. Not only the ability to create and delete objects in that bucket, but also to potentially even delete the whole bucket itself and all the buckets inside of your AWS account. So what we need to do is we have to scope our access to specific actions, like only creating and reading objects within the S3 bucket. And we need to scope it to the specific S3 bucket that we're trying to access. So this is what a proper permission statement looks like. And you can start to get the sense like it's there and it's kind of human readable, but you really have to get into the finer details of how permissions are really managed inside of your cloud service provider. And so you start to think to yourself, well, I'm now moving to a serverless model where I have lots of functions and I have lots of managed resources, buckets and topics and tables and queues. Now I have to figure out how to do this for every function and resource. Because in the past, I might have a monolithic approach where I've got one server that talks to one database and is fronted by load balancers, and I only have to deal with one IAM policy. Now I've got to have separate IAM policies for every function, addressing every different managed resource. So how can I do this in an efficient way? And the first option is, well, let's take our old approaches and see how they work in the new model. So developer hand codes IAM policies. Principal architect will then review the policies, or maybe a SecOps team. Your DevOps team then will deploy the policies. And finally, you can go and use your policy. But if you try to apply this to every time that you're going to update your application and add a new resource or modify its behavior, that's going to be very time consuming. And those same developers who are so excited about serverless are now going to be really pissed off that you are holding them back as an organization by enforcing all of these requirements for IAM policies. So you quickly think about, well, what if we just let everyone do it all themselves? We just give them unfettered access. And within 30 seconds, you realize that that's a really bad idea. So you move on to option C. You realize that, well, what I really need is I need the tools that I use to help me generate these permissions automatically. So if we go back, we've got our architecture diagram. We've codified how our uploads bucket is integrated to receive messages, or the resizer function will receive messages when an upload occurs. The resize bucket understands what the location is of my resized bucket and my resize records table. Our framework should be able to use relatively normal rules that say, well, you know what, that function probably should have basic CRUD operations on the buckets and on the table here. So why don't we automatically generate these at deployment time? So if we have our framework, and again, this is something that is just kind of percolating in through all the frameworks in serverless land. But if we have our framework enabling us, our tools to enable us to create these policies automatically, we can achieve faster development. We have less errors because we don't have to go and figure out and potentially have a typo in our complex policies. And we also get compliance benefits throughout the organization when everyone knows exactly how policies are created and generated and maintained. So this is something that I think we'll see in the future as frameworks continue to evolve over time. So that addresses one of the key points that organizations hit when they want to adopt serverless. Let's start to talk about collaboration mechanisms. So you might think to yourself, well, I know how to collaborate with my teammates to develop applications. Usually, a lot of it comes down to using Git and my normal Git flow workflows. So what more do I need here? And there's a specific set of challenges and benefits that serverless provides that kind of changes a little bit about what you need beyond the scope of source code collaboration. Serverless, one of its benefits is that it can be cheap enough that finally every one of your developers on your team can actually have their own instance of an entire application without you worrying about what is this going to cost me? How many instances, how many EC2 machines or Docker containers are going to have to be running constantly? Or I have to hamper my team to always remember to shut things down when they're not using it. With serverless, you only pay for when you actually use your application. So you can have your entire team running their own instances of their own application and not worry about the cost being too high. So that's a benefit, but one of the challenges of serverless is that local development and testing is difficult. And we'll come back to this in a little bit. But that leads to specifically wanting all of the developers on your team to be able to provision into AWS themselves. And often what that means today is, at best case, all the teams within an organization may have their own AWS account, but oftentimes the entire organization may have one developer account and then a staging and a production account. So you have to find ways that your development team can collaborate within the shared AWS accounts that you have access to. And the main problem with collaborating in the serverless space today is that resources require unique names. You can't provision two functions with the same name into the same region of the same AWS account. It just doesn't work. So now we need to think about how we provision resources so that every developer can have their own copy of things. And the solution is pretty straightforward. It's that we need to be able to namespace our resource names. So if we take one look at how that's possible with one framework, we've got an example from the serverless framework here. And we've got a couple functions here. And the serverless framework has something called a stage that you can use. And a stage is named, it might be something like the dev stage, the production stage, the staging stage. And it's a powerful concept, but by default, your functions don't have those stages, those stage names incorporated into them. So you have to remember to go into all of your resources and add or prepend or append the stage name to your function resource identifiers to make sure that they will never conflict. And it's very easy to forget this. Maybe you spin up a DynamoDB table and you forgot to namespace it. Well, you can't go in and rename that DynamoDB table. You have to find a way of copying the data away, creating a new one, migrating the data in it. It's not a simple operation. So it's a bit error prone. What we really need, again, looking at the frameworks at our disposal, we need a way to have our resources automatically mixed with a sense of an environment of some sort, and automatically creating these namespaced resources for us. So when you have the combination of a really good source code management collaboration platform and your own environments through namespace resources inside of your cloud providers, that tends to really help developer collaboration. So finding tools, finding frameworks that really enable you to automatically namespace things is a key win for organizations. So let's look at testing now. Testing is something that, as I said, most people, when they ask me, they ask us questions, they've just started playing with serverless, one of the first things is, yeah, but how do I test this? Because I'm used to running all my tests locally on my laptop, and I haven't found a good way to do this with serverless resources. And the reality is that Serverless itself does not change testing, but serverless has to change how we run our tests. So there's a key distinction there. If we break it down into the types of tests that we tend to build, we can start with unit tests. And in fact, this doesn't change and may even be easier to architect than ever before. When you're building serverless functions, the compute resources, it's easier than ever to have these boundaries. What does this function do? What is its input? What is its output, its response? And then I simply just mock up some services. And now I can, whether I do it in the cloud or I do it on my laptop, it's very easy to invoke the entry point to my function and see what the response is and what other services through the mocks may have been called. So that's the same as always and potentially even a little bit easier to architect. But when it comes to system tests and integration tests, this is where things get challenging, where we really need to be able to test how does function A that interacts with table B and bucket C, how does that actually occur in a way that I can be confident that my testing environment mimics faithfully what will actually happen in the cloud when I really deploy it. So there's two schools of thought that have kind of emerged in the testing mechanisms for serverless. The first is to just bite the bullet, always test in the cloud. Find a way to deploy your application into a test environment and run your system and your integration tests there. The second is to find ways of providing fake services for local testing. So a fake service is kind of like an extension to a mock. You've got your function. You can run that function on your laptop, but that function has to interact with an S3 bucket. Well, what if instead of that having to interact with the S3 bucket in the cloud, you spin up a Docker container, maybe, that has the same REST API as Amazon S3 buckets. And you just tell your function that instead of using an endpoint from AWS, the endpoint is now in my Docker container over here. It behaves the same way, it operates the same way. That's a fake. So let's talk about the pros and cons of these approaches. If we talk about integration testing in the cloud, the strongest benefit for it is that it is a faithful representation of your application as it will run in production. You do not have to figure out permissions, resource limits that maybe your local testing environment would never even conceive of having to account for. By testing in the cloud, especially with like throughput tests, you can be sure that if you write your tests right, the same behavior is going to happen in production as it does in your test. The other benefit of it is that everything about it is possible today, which we'll come back to when we look at local development with fakes. The downsides of testing in the cloud is that it tends to be slower. You have to find ways of redeploying your functions and your resources every time that you make a change. So if we think about, I realize I have a typo in my code base, how long does it take for me to redeploy that into the cloud and retest it? It can take on the order of a few minutes for just normal use cases, not even some of the more complex changes that you might have to make. And it requires cloud access. So if you don't have Wi-Fi, you're on a flight that's going over the ocean, you can't do development. Though when developers tell me that, I then ask them how often are they actually in planes and out of Wi-Fi. But it is something that you feel more comfortable when you know that you can do all of your development without needing the internet. So let's look at that and compare it to testing locally with service fakes. The benefits are that it's much faster. You make a one-line change to your code. You can immediately invoke it on your laptop. You don't need to re-provision anything. And it doesn't require cloud access. It doesn't require internet. But the downside is that there's potentially skew in behavior versus the cloud. The limits, the permissions are hard to test for, and it's not very well supported today. So what I mean by that is you can find fake versions of a S3 bucket, fake versions of a DynamoDB table. In fact, you're starting to see that upstream projects like AWS SAM has something called SAM Local, a local utility for spinning up functions and API services that do make this possible. But in the case of SAM Local, it only makes it possible to hook together an API gateway and set of endpoints to functions. So there's still no automatic faking of S3 buckets and DynamoDB tables. So it's kind of challenging in that it's not actually possible today without a bunch of extra grunt work on your part to create and instantiate these fakes. So my advice the advice that we give to our customers today when it comes to testing for integration and system tests, and it's for today only because this is a rapidly evolving field, and maybe a year or two down the road we'll have a really good fake local development story. But basically it boils down to if your application is only API endpoints and functions backing them, then there are lots of good ways to do local testing. Otherwise, it's much easier to deploy into the cloud and test. And then they ask me, yeah, but how do I easily spin up a testing environment in the cloud that's separate from production and staging? And I say, well, we already solved that. Again, go back to namespace your environments, have your frameworks do that. You can just spin up another test environment. So with the right approach, serverless is not a hindrance to testing. You just need to find the proper ways to do testing that matches the needs of serverless applications. So lastly, I want to talk about monitoring and instrumentation, which is key when you need to push things out to production, both to figure out what went wrong when you need to fix it, but also to proactively monitor and know what will go wrong if you don't address it beforehand. So how we do it today, typically an organization picks a set of monitoring tools, usually for the entire organization. One log provider, one metrics provider, one error aggregation service. Then they ask everyone to always instrument using those providers and instrument in the same way. And this is easy when you've got a few monolithic apps. You just sprinkle in the monitoring agents in a few places, and you're good to go. But when it comes to serverless, we have so many more functions. We have so many more resources that we have to monitor that it becomes tricky to always remember to monitor, to instrument your monitoring tools. So then organizations tend to fall back to praying. And when that fails, draconian measures, which no one really likes, and again, developers will hate it, and they'll ask like, why are you holding me back from my joys of doing serverless development? So how we should do it is, again, an organization should pick a set of monitoring tools, but then define instrumentation rules centrally. One place to say we're going to instrument with logly for logs, rollbar for errors, and somehow, and again, the somehow is framework and tools, automatically instrument your code, your functional code, every time that you are building it. And then go and eat cake. So how can a framework auto-instrument the code? Well, let's take a very simple functional handler here. It just adds two properties of an event together. And this is in our index.js file. We can drop in a little extra file called instrumented.js. And what this file does is it will load, it's got its own handler, it will load our index.js handler, and then it will invoke it, but it will do so in a try-catch block. So that if an error occurs, we'll catch it, and we can then decide to do something with it. Like in this case, we'll send it off to rollbar. So let's say that we take every one of our functions that has an index.js and we drop in this instrumented.js file right next to it. All we have to do now is update our handler that we're going to call from index.handler to instrumented.handler. And now we haven't changed any of our application code, but now every time we run our application, if an error occurs, it will automatically get caught by our instrumented handler and sent to rollbar. So that's a mechanism by which if you incorporate instrumentation into your build process for your functions, you have this capability of automatically instrumenting your applications across your organization. So lastly, people tend to ask me in our company, help me understand what are great tools for this monitoring and instrumentation space for serverless. And I want to kind of give a small diatribe in person here, because it changes quickly as more new tools come into place. But there's basically 4 categories. When it comes to metrics, you can start out with CloudWatch metrics, and Microsoft has their own metrics platform. Google has their own metrics platform, and they tend to work decently well as you get started. But a great tool once you graduate beyond what they provide here is IOpipe for giving you metrics and a little bit of error aggregation, I believe. For logging, I don't have a huge horse in this race, but I do know that a lot of the customers that we've worked with have used Splunk. So they've found that works really well for them. For tracing, there's, again, a lot of the cloud providers have a solution. There's AWS X-Ray. Microsoft, again, has Application Insights that can provide this. There's also a new startup out of Israel called Epsagon that is doing serverless-specific tracing, which is very interesting. So I haven't used it, but it's worth checking out. And lastly, for error aggregation, we use Rollbar internally at Stackery. We love it. There's other tools. Many application performance monitoring providers have their own versions. As I mentioned, I believe IOpipe does. New Relic does. But having an error aggregation solution really helps in addressing problems as they occur. So those are the 4 key areas where we have consistently seen organizations that they come to us at Stackery, they want to build serverless applications, but they need help. These are the main areas. So the question is, as you are going to build your serverless applications and your development teams that are going to build serverless applications, how will you manage these gaps? And you can build all of these things yourself, but that tends to end up being a lot. So an alternative approach, this is the tiny commercial at the end of the talk, Stackery is a solution off the shelf that our customers have used to help us with all of these types of serverless lifecycle challenges and many more. We'd be happy to talk with you about your needs in this space too. Thank you.
All right.